Hello everyone, welcome back to my channel. In the previous video we have discussed about exercise 1.3. This is continuation of the first chapter. In this video we are going to learn about operations on real numbers. You have learnt in the earlier class that rational numbers satisfy commutative, associative and distributive laws for addition and multiplication. 8th class lo మీరు రేషనల్ నంబర్స్ కాంపిటేటివ్, అసోసియేటివ్ అండ్ డిస్ట్రిబ్యూటివ్ లాస్ ఫర్ ఎడిషన్ అండ్ మల్టిప్లికేషన్ సాటిస్ఫై చేస్తాయని నేర్చుకున్నారు. మోర్ ఓవర్ ఇఫ్ వీ యాడ్, సబ్ట్రాక్ట్, మల్టిప్లై ఆర్ డివైడ్ except by 0 or two rational numbers, we still get rational number. అంటే any two rational numbers, if you add or subtract or multiply or divide except by 0, then we'll get ఓన్లీ రేషనల్ నంబర్. అంటే టూ రేషనల్ నెంబర్స్ని యాడ్ చేసిన, సబ్ట్రాక్ట్ చేసిన, మల్టిప్లై చేసిన ఎనీ టూ రేషనల్ నెంబర్ ఐదర్ పాజిటివ్ ఆర్ నెగటివ్ ఎక్సెప్ట్ డివైడ్ బై 0, then we get the rational number. You learnt in the earlier classes. So by this we can say that the rational numbers are closed with respect to the addition, subtraction, multiplication and division. See, by addition or subtraction or multiplication or division, if we get the same rational number, the rational number satisfy the closure property under addition, subtraction, multiplication and division. It turns out that the irrational numbers also satisfy commutative, associative and distributive laws for addition and multiplication. So in the same way, irrational numbers also satisfy commutative, associative and distributive laws for addition and multiplication. రేషనల్ నంబర్స్ ఎలా అయితే ఈ ప్రాపర్టీస్ని సాటిస్ఫై చేసాయో, ఇర్రేషనల్ నంబర్స్ కూడా ఈ ప్రాపర్టీస్ని సాటిస్ఫై చేస్తాయి అండర్ ఎడిషన్ అండ్ మల్టిప్లికేషన్ ఓన్లీ. However, the sum, difference, quotient and product of irrational numbers are not always irrational numbers. So sum or difference, sum add చేసిన, టూ ఇర్రేషనల్ నంబర్స్ని యాడ్ చేసిన, సబ్ట్రాక్ట్ చేసిన, డివైడ్ చేసిన లేదా మల్టిప్లై చేసిన, దే ఆర్ నాట్ ఆల్వేస్ ఇర్రేషనల్ నంబర్స్. అవి ప్రతిసారి ఇర్రేషనల్ నంబరే కాకపోవచ్చు. So that means, look here we have some examples. Sum of 2 is root 6 is irrational number and minus root 6 also irrational number. Root 6 plus of minus root 6 is 0. Is 0 irrational number? No, 0 is not irrational number. So sum of two irrational number is not always irrational number. Here we got the 0. 0 is a rational number. So now difference of two irrational number, root 2 minus root 2, both are irrational numbers, right? Their difference also 0. Root 2 minus root 2 is 0. Third example, root 3 times root 3. Root 3 times root 3 is root 3 whole square. Square and root get cancelled. Then root 3 whole square is equal to only 3. 3 is a rational number. So product of two irrational numbers, we have product is a rational number. Root 17 divided by root 17 is 1. So quotient of two irrational number is a rational number. By this 4 example, we got all in the 4 example only rational number. Look here, what happened when we add a multiply a rational number with an irrational number. See, here we added two irrational number, found a difference in the two irrational number, the product of two irrational number and quotient of irrational number. But here we are going to finding the sum or difference or product or division of a rational number and irrational number. Look at this. What happened when we add, multiply or multiply a rational number with an irrational number. For example, root 3 is an irrational number. What happened? What about 2 plus root 3 and 2 times root 3? Since root 3 has a non-terminating, non-recurring decimal, that means it is an irrational number. The same true for 2 plus root 3 and 2 times root 3. Therefore, both 2 plus root 3 and 2 times root 3 are irrational numbers. So, root 3 value is 1.732 and so on. If we add 1.732 to 2, so that is 3.732 and so on. Again we get a non-terminating, non-recurring decimal as a sum of 2 plus root 3. So it is sum of a rational number and irrational number is also an irrational number. 2 times root 3. So multiply root 3 value, which is 1.732 and so on, by 2. Then you get product is also an irrational number. 11th example. Here we have 4 cases, 4 questions. The product of a rational and irrational number, division of irrational number by irrational number, sum of irrational and rational number, difference of irrational and a rational number. So the product of 7 and root 5. Root 5 value is 2.236 and root 2 is 1.4142 and so on. Pi is 3.14115, 1415 and so on. So substitute these values in the given operations. In the product, 7 times root 5 is 15.65 and so on. This is also irrational number. And 7 divided by root 5. So rationalizing the denominator by root 5 by root 5. Then we get 7 times root 5 by root 5 times root 5 is 5. So already we know what the value of 7 times root 5. 15.652 by 5 is 3.1304 and so on. So the quotient also an irrational number. Here numerator is irrational, denominator is rational. Their quotient is irrational. Look at root 2 plus 21. Root 2 value is, here we have root 2 value 1.4142 and so on. It is a non-terminating, non-recurring decimal. So if we add this non-terminating, non-recurring decimal to 21, then we get 22.4142 and so on. So this is also an irrational number. So next, the fourth one, pi minus 2. Pi value is an irrational number which is 3.1415 and so on. So if we subtract only 2 from this irrational number, then we will have 1.1415 and so on, which is non-terminating, non-recurring decimal. In these 4 cases, we conclude that a sum or difference or product or quotient of a rational number with irrational number is an irrational number. Now let us see what generally happens if we add, subtract, multiply, divide, take square root and even nth root of these irrational numbers, where n is any natural number. Let us look at some example. So 11th example, rational number by irrational number operations చేసాము. In the 12th example, we are going to discuss about irrational number by irrational number. Look at this, 2 times root 2 plus 5 times root 3 and root 2 minus 3 times root 3. So 2 times root 2 plus 5 times root 3 plus root 2 minus 3 times root 3. 5 times root 3 and 3 times root 3 are like terms. So 2 times root 2 and only root 2 are like terms. We have to add these two and these two separately. 2 times root 2 plus 1 times root 3 is 3 times root 2. 5 times root 3 minus 3 times root 3 is 2 times root 3. So we get, in this addition, we got again irrational number. So look here, multiply 6 times root 5 by 2 times root 5. So multiply the whole numbers separately and radical numbers separately. So 6 2s are 12. Root 5 times root 5 is 5. 12 times 5 is 60. See, so the product of two irrational numbers is need not to be irrational. It may rational. Sometimes it may rational number. Divide 8 times root 15 by 2 times root 3. Solution 8 times root 15 divided by 2 times root 3, rationalizing the denominator. So 2 times root 3, you can cancel 8 by 2, 2 ones, 2 fours, and root 3 gets cancelled. Then 4 times 5 only the answer. So by those examples, then we conclude that the sum or difference of a rational number and a irrational number is irrational number. Sum or difference of rational number and irrational number is always irrational number. The product or quotient of non-zero rational number with an irrational number is irrational number. Non-zero, if it is a zero, product of zero and irrational number, again we'll get the rational number. అందుకని ఇక్కడ నాన్ జీరో రేషనల్ నంబర్ అని పర్టికులర్గా మెన్షన్ చేశారు. అండ్ మోర్ ఓవర్ ఇన్ ద కోషెంట్ irrational number divided by 0 does not exist. అందుకనే నాన్ జీరో రేషనల్ నంబర్తో ప్రోడక్ట్ కానీ కోషెంట్ కానీ డివిజన్ కానీ మల్టిప్లికేషన్ కానీ చేసినప్పుడు వచ్చే రిజల్ట్ ఇర్రేషనలే అవుతుంది. If we add or subtract, multiply or divide two irrationals, the result may be rational or irrational. See, remember this. రెండు ఇర్రేషనల్ నెంబర్స్ని యాడ్ చేసినా, సబ్ట్రాక్ట్ చేసినా, మల్టిప్లై చేసినా లేదా డివైడ్ చేసినా ద రిజల్ట్ మే బి రేషనల్ ఆర్ ఇర్రేషనల్. రిజల్ట్ అనేది ఖచ్చితంగా రేషనల్ అవుతుందని కానీ ఓన్లీ ఇర్రేషనల్ అవుతుందని కానీ చెప్పలేము. సమ్టైమ్స్ ఇట్ మే రేషనల్ అండ్ సమ్టైమ్స్ ఇట్ ఈస్ irrational. We now list some identities relating to square roots which are useful in various ways. ఇక్కడ మనం we can see some identities which are useful in different ways, various ways. Already familiar with some of these in the earlier classes. The remaining ones follow from the distributive law of multiplication over addition for real numbers and from the identity x plus y into x minus y equal to x square minus y square for any real number x and y. అసలు ఐడెంటిటీస్ అంటే ఏంటి? ద ఐడెంటిటీస్ ఆర్ ఆల్వేస్ ట్రూ ఫర్ ఎనీ వాల్యూ ఆఫ్ సచ్ వేరియబుల్. అంటే ఎక్స్ వై వాల్యూస్ ఇఫ్ యూ ప్లేస్లో వేరే వాల్యూస్ ఏది తీసుకుని సబ్స్టిట్యూట్ చేసినా కూడా అంటే ఇఫ్ ఎక్స్ ఈజ్ 2 అండ్ వై ఈజ్ -3, if you substitute in this equation is satisfies for any of the values. It is true for any of the values of x and y. Such equations are called identities. So what are the identities? Root a b can be written as root a times root b, and root a by b can be written as root a by root b, and root a plus root b into root a minus root b is a minus b. How it is possible? Root a minus root b is root a whole square minus root b whole square. Square root gets cancelled. Then we get a minus b. Root a plus root b times a minus root b is a square minus b. This is also in the form of a plus b into a minus b. Then a square minus b square. So already we have the square root. So square and square roots gets cancelled. Then we get a square minus only b. Root a plus root b into root c plus root d is equal to under square root ac plus ad plus bc plus bd. The fifth identity is root a plus root b whole square, which is in the form of a plus b whole square. We already know about the a plus b whole square formula, a square plus 2ab plus b square. But here this is the root a. So root a whole square means a. Square and root gets cancelled. Only a we have. and 2 times root AB. Root A times root B is under root AB plus root B whole square. Root B whole square cancelled, then B only here. So these are the most useful identities. So next exercise 1.4 is based on all these. Using these identities, we are going to solve the questions. We have one note here, remark here. So what the remark is? Note that simplifying in examples above has been used to mean that expressions should be written as sum of the rational and irrational numbers.